All right, good morning. Thank you for joining us. This is using Gen AI to optimize ground segment operations. My name is Randall Barney. I'm the Executive Director for the World Teleport Association. So in addition to making headlines, generative AI is finding practical uses in the space and satellite industry. As ground segment operators strive to adapt to fast change in markets, they are finding early uses for Gen AI in such business standard areas as marketing and customer relations. The future may hold greater opportunities in code development, cybersecurity, antenna scheduling, equipment monitoring, and interference detection. In this panel, we're going to discuss our teleport operator members are going to share their current experience with Gen AI, the avenues they are exploring, and the values they are uncovering, and the potential competitive advantage they can provide. So real quick, I'm going to ask each of my panelists just to give us their name, title, and company. No advertisements at this point. We'll start with Frank.
Hi, my name's Frank Czulo. I'm the president of the Advanced Networks Division of Network Innovations.
And good morning, my name is Mudge. I'm the CTO for Speedcast.
Good morning, I'm José Sánchez. I'm the Chief Operating Officer of Hispasat.
My name is Thorsten Stremlau. I have a dual hat on today. I'm here representing Trusted Computing Group from a security perspective and NVIDIA from an AI perspective.
All right, and we're going to stick with you, Thorsten, for the first question here. Before we dive in, let's first define what we mean by AI, Gen AI, and machine learning.
Oh, wow, okay. I'm going to put it really, really simply. This is a term that's commonly confused. So let me be very, very clear, and I'm going to, as I said, really, really simply, AI is the concept of applying a computer to understanding data, right? And by the way, it's been around for decades. That's nothing new. Machine learning is the concept of now getting a computer to identify patterns in the data, right? And that's really, really simple. So, if you want to find a flower in a picture, that flower will have a pattern. And so, or by the way, in satellite operations, signal strength, disturbances, et cetera, those are all the different types of patterns that machine learning has. And machine learning is a part of AI. Underneath that, machine learning comes Gen AI. So Gen AI is leveraging the information that you learned from applying machine learning and generating or translating that into new data, right? So you can now model something based on an established pattern. So if you know that this is a disturbance that's caused at 2 p.m. every day because of this, then you can interact with it and have it generated. One last thing, I'm sorry, I got to do this. So when you chat with a ChatGPT, I want to be very, very clear, it doesn't know what it's answering. It's just simply adding the probability of words in a sentence back to you. It doesn't know what it's saying. It's just a sequence of probability of words when it's answering your questions. Okay? So I hope that answered that question. That was a commonly asked question.
Right. So how are teleport operators and ground segment operators currently using Gen AI or AI in their operations? I'm going to start with you, Will.
Sure, I'll take a stab at it. So at Speedcast, we operate many teleports. And like Thorsten said, this is kind of a process that you build on. The first step is the data. You have to have a database that has all the data that you can then start to apply machine learning algorithms that then can learn AI algorithms so that you can build upon it. For teleports, it's been a challenge because a lot of the systems have been disparate over the years. So the ACUs are from multiple ACU manufacturers. They don't have databases in them. Amplifiers, LNB systems, you can imagine all the different pieces, up converters, down converters, line amplifiers, all the different pieces that go into it. The first step is to try to capture all of it into a database that you can start to apply machine learning. And we've been using machine learning in our databases and our teleports for years, where we start to pull that data in. The next step for us is cleaning that data up in a way that the machines can understand it, and so that you can start to generate AI outcomes of it. So while we continue to build our AI infrastructure to be able to respond more holistically, we still use AI in complementary areas outside of it and part of the program. So of course, cybersecurity, RFPs, things like that, places where you can use it. There are those types of things that complement the business. It's not always just about the hardware and the amplifiers and the pointing systems, there's other ways that you can bring it to bear, but it is really important to have all that data and a method that you can use it and that the machines can understand it.
Okay, great. Frank, can you continue on that question?
Yeah, I'll kind of follow on. Will and I often do this, apparently, but where Will has teleports, we tend to build with multiple bearers on the network aspects of things. So we're looking for quality of paths. Network Innovations is predominantly or 60% government customer base. So we're doing things like assessing threat surfaces and things from different aspects. And what we've learned, and I love the definition because I still struggle with the difference between generative AI and AI. What we've learned is we can use AI to speed up our solutions and our modeling for using multiple bearers. In today's communication world, having 10 or 15 different paths is not uncommon. And then partnering, say, with, and Will and I will have to talk about this later, but signals intelligence is now becoming a huge issue in interference mitigations and things like that. So when we can pull data in from teleports and then put it into a large model, you now actually have almost a visual representation of space, and it's great when it comes to mitigating interference in the RF spectrums.
Okay, great. Jose, as a satellite operator and a teleport operator?
And service provider.
And service provider.
So yeah, I mean, as we go through the questions, we will understand why we are where we are and not in another place. But to answer your question, what we're doing today is basically running some POCs, some proof of concepts on using AI with data, but not necessarily in production, but to better understand how this can be used as a very powerful tool. And we are following very closely what the telecom operators and particularly mobile operators are already doing, because they are ahead in implementing this and trying to see from their experience how we could leverage on AI more efficiently. Right? It's very important to understand also where you're going when you are implementing AI in operations, have a clear picture of your objectives before you start doing real cases, real implementations, and then progressively move from the POCs to certain implementations that then will become even part of the services, right?
All right, what have been some of the early successes or unexpected challenges that you've encountered while integrating Gen AI into your workflows? Will, you want to start there?
I'll start off on this one too. I think the first one that was interesting to us was, where does your data go? Right? When you chat into ChatGPT, it sends it off to ChatGPT, which is somewhere not at your facility. And then what they're allowed to do with that data that you don't have control of, right? Because it's now left your facility and it's gone somewhere else. So when you look at your AI policies, and we're an international company, we have a lot of people that are non-English speaking. So they use AI in the meetings to help translate the meetings and get information out, and it's a very useful tool for them, right? They love it. But it's very dangerous for us because now you have internal meeting information that's going out to somewhere and you have no idea what's going on with it. So if you take something that's that basic, like a meeting, where you're using it for a very good reason, right, which seems fairly benign, but now you're going to take your teleport data or your customer's data and you're going to put it out there. How do you do that in a way that you can feel secure about that it's going to happen? And for us, I think that was one of the early learning challenges that we've working to overcome on how do you design the systems with the end in mind so that you can accomplish your goal but do it in a way that's secure for your business.
Okay. Frank, early successes or challenges?
Single biggest challenge is security. Will nailed it. We deal one of our main products is obfuscating the path to make the path disappear. When you're using AI, you can't leave the breadcrumbs of what you're doing. So a lot of it was, I'd say to Jose's point, was really being very specific as to where we were going to try to apply it, and then using a private model or using a very generic modeling scenario that we didn't let the machine learn too much, I guess is the idea, right? And it's a very fine line because it is a very powerful tool, but knowing where your data is, and particularly in our case, if we're designing a very bespoke solution, we do not want that bespoke solution becoming public knowledge.
Jose, challenges?
So yeah, well, data sourcing is key, right? And filtering and cleaning and having the proper information, that's essential. So in that sense, what we're doing today is that we are rebuilding our systems, and the architecture we have designed has been done in such a way that AI is part of the solution, right? Beyond that, of course, you are going to face the challenges of implementing any new technology, any new tool in your system. So you have resistance to change. You need new skills in your team to implement all that. So this is generic to whatever, but it also applies to developing and implementing AI in your operations. And then something very relevant is also, as I said, you have to have an objective, and you have to do some analytics before you start using AI. You need to exploit the data and understand what the data can bring before just going and plugging a system, because it's not just buy a box, plug it in, put the data, and something magic is going to happen. You have to work before on what you want to achieve, right?
All right, Thorsten, any challenges or successes from your perspective?
Yeah, so from the projects that we're working on, I'd like to focus on the security side of things. I think there's 4 core areas. Number one, I think you mentioned it, is the source of the data, right? You have to make sure that the data that you're feeding in, and I'm just going to say is, crap in, crap out. Okay, I usually use a different word for that, but I'm going to not say that. And so the source of the data is something that's really important. If you're getting irrelevant or bad data, it's going to pollute your AI. It's going to pollute the ML part of everything, because it's going to learn the wrong thing. Second thing is then, once you've invested $100 million in an NVIDIA-powered data center, right? And you've now invested countless hours in that data center analyzing all of that data over a period of, let me be very clear, it costs money to process all of that data. The result of which is a model, right? Which is going to be your particular model to your particular company. You've invested, let's say, $100 million into that model. You don't want that model to now leave your company, so you need to protect that model once you've trained it. Then we go into the third one, which is you're going to continuously be improving on your model. So you need to make sure that any new training data is also not polluted and is coming in from a trusted source, right? So that there's no anomalies that are now suddenly being reported in, because they will again skew your AI, right? And then lastly, I guess, is in the fourth area, is making sure that you get rid of hallucinations, right? Hallucinations in AI is when AI suddenly makes up stuff. Okay, remember, AI is all about probability, right? So the probability of me saying, I hate or I love you, those are 2 different probabilities, right? And that's all that AI does. It just determines whether I'm going to say those 2 words. And so you have to put barriers in place so that your operator that is now using ChatGPT or using the AI in order to generate code or do something else like that isn't generating hallucinated data that suddenly crashes your entire network. So those 4 areas are really, really important to that particular, and all of them have to do with security.
Great. I just want to point out we have a microphone. If the audience has any questions, please, and I do want to encourage participation, please use the mic at the center so that we can all hear the question. So how can Gen AI enhance antenna scheduling and optimize spectrum usage for teleport operators? And Frank, I'm going to pick on you this time.
Yeah, so I have a pet project, which is the idea of having more access to teleports on a more convenient way, and I mean convenient in the fact that much like, say, a terrestrial fabric where we could just simply go book an hour here or 5 days there or 6 days there, that scheduling, that whole coordination from a teleport standpoint is ideal for AI, because I have characteristics of networks that I want to have, and say Will would have characteristics of certain carriers that he has. Marrying those together and knowing that they're available is a massive amount of data that's going there. The challenge in the security aspect to it, because I want to just touch on that a little bit, is I also have to be conscious that my model is not generating a data set for somebody else's model. Mm-hmm. Yeah. And what I mean by that is my model can say AT&T on Friday afternoon at 2 o'clock on a cellular service is terrible, happens all the time. Therefore, I'm going to switch over to a teleport to move my path that way. In the Intel side of things, somebody else can be watching where I'm switching my paths to and then start figuring out what I'm doing. So from a scheduling standpoint, it's absolutely great. From a security standpoint, it scares the crap out of me when we start doing that side of things. So I wish I could profess I was an expert, but I'm learning as we go.
Wait, Will?
So I think in the traditional sense, AI is a bit challenged in how we've operated geo today, and I think like Frank alludes to, and we always compliment really well, I love it, is that in the world going forward, we need to find better ways to do this, and AI is a way that can make this happen. When you look at the geo world, the ability to schedule also relies on the baseband equipment and standardization and connectivity to those sites, and that can be a bit of a challenge. But we're getting better. We're getting better every day at how we can get to those places and schedule it. The satellites are getting better. Now you can start to schedule on satellites. As we look at LEO, and we're adding LEO, whether it's Earth observation or data, there's a lot more scheduling that can happen with these things as well. So this is very much a growing part of what teleports is. The part that Frank mentions is absolutely critical to be able to help the geo environment that we have today to grow. Because at Speedcast, we're all about our end customers, right? We service the end users, not just the satellite providers. And they're demanding more data at a lower cost point. And to do that, we have to drive efficiencies, which means you can't necessarily book a month when you need a day, right? But there's other requirements that go along with it. So as we look at our tools, and back to Thorsten's point, because I 100% agree and aligned, the data has to be right. You got to get the data right. You have to be able to enter it the right way, and then you can set your scheduling system up, whether it's for an hour on a geo network, or whether it's for an Earth observation satellite passing over, or whether you're scheduling for a data LEO, direct to cell, whatever. All of that requires that base data to be there and captured.
Okay, great. Jose, we'll come back to you, but we have a question here in the audience. Is the mic on? Should be on now.
Hi. Do you see AI replacing like human capabilities, and if so, to what degree?
Why don't we start with you, Thorsten, to give the big view on that?
All right, that's a very loaded question. So I do want to be, again, I mentioned hallucination. So we're at a stage now where, for a vast majority of the more advanced AI stuff, you still need a human in order to double check it, right? That's one of those things that's there. It's very, very good, as I said, at detecting patterns in data. But, you need somebody to double check it. There are things like, for example, chatbots, talking to a PDF document, right? Your end user interaction for a help desk, right? Those are things where you can teach your AI the top, 100 frequently asked questions, and then have it walk a end user through troubleshooting. Those things, those more simple jobs, are things that I do think can be used and to replace people in the job. But for the more advanced things like double checking on the schedule, right, making sure that the signal integrity is there, and also then looking at and I've seen a number of companies here looking at digital twins of your environment, changing parameters within that digital twin in order to see what would happen, and then double checking whether that data is also correct. So so to answer that question simply, I'm going to repeat one more time. Simple jobs, yes, is something that a Gen AI can take care of. More complex things are things that will still require human interaction.
Yeah. All right, we're going to come back to something along that topic, but Jose, I wanted to give you a chance to talk about antenna scheduling and optimizing spectrum.
So the two things are good examples of what you can achieve with the AI, not only for that, but for many other things, right? So the first thing is you have a massive amount of data, right? And you can quickly analyze this data, and based on that, optimize the usage of your resources. So you can optimize the usage of your antenna park, and actually you can actually re-optimize in real time based on different objective. So at a given time, with a pool of requests, you can decide this is the optimal setup, right? And I can maximize that maybe with an efficiency on cost saving or whatever. But then after that, I go to rush hour, and my target is going to be maybe maximize incomes, and not basically reduce cost to the maximum. And then I can set up a different arrangement. And this amount of data, a human cannot process that quickly and come to such an efficient setup, right? Then another thing that can bring is prediction, right? So predicting what is going to happen in the future based on history and based on actual data, it's something extremely powerful that can anticipate usage, so you can prepare resources, or can anticipate faults, so you can anticipate maintenance, or can anticipate, for example, bottlenecks, so you can take actions on that. So there are a lot of things that can be done.
Okay, well, and continuing on that, what ways can AI-driven automation improve network monitoring, equipment maintenance, and anomaly detection? Will or Frank, you want to start with that?
I'll grab onto that because I'd like to give you a quote that I'm stealing from somebody. I don't know who said it, but this: don't be scared of AI taking your job. Be scared of humans who know how to use AI taking your job.
Yes.
And then I wish I could attribute it to somebody, but we see it, and to José's point, things like predictive analysis on failures or networks or things like that, we always wanted to do it, but the cost benefit was never there. You're not going to spend 5 weeks doing a predictive model for something that's going to save you $1,000. Now, you don't spend 5 weeks. You can save the $1,000 in minutes because you want to see the predictive model. So I like to think of it from our engineering side, that it's really enhanced our engineers. It frees them to think, right? Because now it's not so much the act of doing. They're like, what if I thought about this? Or, the one thing that we forget about in AI is it's artificial intelligence. We're still the possessors of the intelligence, the real stuff. So what I find is it's an amazing tool to allow our people to do their what-if analysis, their thoughts. It actually frees them to have a massive whiteboard to look and run their ideas, and things that weren't cost effective in maintenance and scheduling and things now are today. So it is about efficiency. Unfortunately, it's also about speed of decision making. So we are living in a world that makes decisions a lot faster than what we used to. But the capabilities and the possibilities for a human to design are greatly enhanced by AI.
Great. Will?
Yeah, I think just to build on it too a bit, and to kind of marry to your question a little bit more, when robots came around, everybody was worried that robots were taking their jobs in the factories, right? And eventually we see those robots taking those jobs, but they do a better job at it, and now we service the robots, or we program the robots. And I think it kind of ties to what you're saying. So if we put it to an application, an actual application of something that we do, we sell Starlink, we use Starlink as an example. We know where they're geofenced, or we know where they have rain fade, right? And if you take all of the ships that are in a particular area, you can figure out where their geofencing is, and you can turn a different service on or a different service off. But if you have one person that's saying, okay, this ship at this latitude, and they plot it, and then so on, it takes a lot of time away from the work that you could be doing. But an AI can infer where that line is based off of simply applying green and red almost to a lot of these things, or as weather passes across, or how intense is the rain, or there's so many other ways that you can use it that brings value to that end user, which makes my life a lot easier, because I don't want to sit in front of a computer all day trying to map these things out of where it is, and then the result is better, and then I can focus on something else. I think which is exactly what you were saying, Frank. It's not that AI is bad for what we do. It's quite the opposite. It's giving us another set of tools that we can use so we can go focus on other problems.
Great. José or Thorsten?
Yeah, I'd like to add something to both what Frank and Will also said is each of us has a particular skill, right? We're not all-rounders, well, hopefully not, but so I'm an engineer. Hopefully, I think I'm a good engineer, but I'm an engineer, but I'm bad at project management, and anybody that's ever met me will tell you that. So the concept, again, from an AI perspective is, as Frank was saying, I want to optimize something, but I need access to a meteorologist. I need access to a project manager. I need access to somebody or something that is highly skilled in one particular subject or topic. That is basically where the direction of Gen AI is going, is where there are highly trained models that would be trained for project management, for meteorology, for all sorts of different types of activities, and by the way, that are provided by the many, many different vendors here, right? So if there's a, if there's a vendor here that's good in materials manufacturing or antenna forming, et cetera, you can book those in to your company, and now you can leverage their knowledge as part of yours in order to do that what if model, right? To see how do I transfer my data in a better way? So that's basically the evolution of Gen AI as it goes forward, is also the ability for an engineer that's bad at project management now booking in a project management AI that helps me organize my day. By the way, I really love it when that happens. My wife, not so much, but I do.
All right.
Jose.
Oh, sorry, Jose, go ahead.
Yeah, so if I can complement on that. So in fact, we are facing two situations. On one side, we have a massive amount of data, every time more and more. And on the other hand, if we just look at the traditional way we were operating, we never had time to do a lot of things. And now we have even less time to do those things, right? And with the AI, with data science, with machine learning, and so on, what we're trying to do is to do all these things that we had never time to do, and do it now quickly, right? So this is helping a lot. And how this is helping? Well, basically, some of the things that brings is the ability to visualize things very quickly, right? And by visualizing things, we accelerate, the perception of the things and the reaction time. We can detect patterns in massive amount of information. I have an example of one of the POCs we have done where we have entered information on interferences and scenarios. We had characterized a number of scenarios, let's say 6, right? And we had troubleshooting processes for the 6 different cases. By entering the data there and trying to model that in order to help us to automate that, we found out that there were 2 additional cases that we were not considering that were hidden there and that require a different way to proceed, right? So this is extremely important, right? So in particular for the question you asked, if we look at a NOC, a Network Operations Center, with all this massive data that monitoring systems are generating and producing, right? We have a storm of alarm when something happens. A massive alarm everywhere, everything is red everywhere, and we don't easily know where the problem is, from where it's coming, how you do the root cause analysis. And traditionally, we were monitoring just a few parameters and doing correlation. So we were saying basically something as simple as, if this happened here and this has happened also there, then this means that this is what was happening. Today, with all this information, it's absolutely impossible to have a human being trying to make these correlations, right? But if you use AI, you can easily simplify all that and identify quickly the root cause analysis. And what is best is that also the system can learn with the time, and you can teach it. And you need the human also to teach the system. And I come to a point that you mentioned. It can happen that in some AI systems, 25% of the information produced is an hallucination. It's not real. It's false, right? But it looks like real, right? So you need to ensure that, and you need to improve the system constantly and so on. The other thing that is very important in a NOC is that we have also a traditional way to classify the events by major, critical, warning, etc., and then focus on those that are more in the major and the critical first, right? But what if we can integrate, for example, the impact that an event is having in the number of, given number of customers, and the cost and the commitment you have with SLAs and so on, so that you can have a classification where a warning is not a major or critical, is having a massive impact in customers and in revenues, and then you have to give priority to that one, right? So these things, you can do it on the fly, right? And this is very powerful.
Turning to cyber threats, how can Gen AI be leveraged to enhance threat detection and response for ground segment operations? Frank, you want to start with that?
Yeah, so I mean that's key to some of our business models is I'm going to make a distinction between cybersecurity or network security and secure networks, and a few people will look at me, with the puppy dog tilt. What's the difference? Our view when we talk about cybersecurity is actually secure networks, which means where is that attack surface available? Where are the points of vulnerability that exist on the network that somebody can try to intrude or detect, as opposed to going through the data aspect of it. So we're looking more at the physical transport side. So the beauty of it is, and Jose alluded to this, is when you start modeling with it, you get a better chance of looking at it. So the idea of say mapping out a path or multiple paths or what have you, and then using Gen AI to say where are my attack surfaces and where are my vulnerabilities, it's sort of that what if analysis, right? So let the machine try to be the attacker, for lack of a better term, and then we can build our networks more resilient by doing it. So we use it for modeling. One, for developing solutions, we can develop solutions a lot faster, but two, for actually guaranteeing the security of those paths.
And Frank, by the way, I want to say is you're not the only one that's using those tools to detect your network vulnerabilities.
Yeah.
So this is actually one of the things that is important is hackers are also using those tools to generate new capabilities in terms of hacking and trying to find new avenues. And that's one of those things that, again, Gen AI has its benefits within that one space, but it's specifically in the area of security, it's also a risk, right? Because there are others that are using that, and therefore, it's something that you need to protect against it.
Just like white and black hat hackers, there's white and black hat AIs.
Which I think, just to kind of keep going on the point, there's a couple of different things to be aware of with cybersecurity. One is the live threats, right? IDS, IPS, things like that, where there's a lot of cybersecurity firms that add AI as part of their offerings when you buy their service. And it helps to look at the traffic that's coming across your network and what could be potentially malicious traffic, what's BitTorrent traffic, what's DDoS traffic, and help filter those things out with very live updates on what the attackers have dreamed up yesterday on their AI machines to be able to combat it. So there's the live fight that's going on. The other one, like Frank said, is identifying the weaknesses within your network, right? Scanning the network, looking for the different vulnerabilities, where you left port 80 open, who's using VLAN 1 or 0, who's using a default password. You can see all of those things across your network and make sure that you're dealing with those as well. And AI does a fantastic job of helping to scan that. There's penetration testing, where you can use AI to try to do your pen testing as well. That's another big piece of it. But processes and procedures is one you can't forget about either, right? How often do you reset your passwords? AI can't always help you with that. So it's not the end-all be-all. It's not the silver bullet to it. You still have to have the human side of it, making sure that you're covering all of your bases, and there's no one thing that can do it. You have to be able to write those processes. AI can help suggest some processes to you, but you have to find something that's going to work for your business at the end of the day as well.
Jose? No?
No.
Okay.
I have one,
go ahead.
one point to throw in on here, and we often talk about cybersecurity as security of the data. Cybersecurity should also, in my mind, is also the idea of using cyber to attack, right? Which doesn't necessarily mean that they have to attack your data. So think of this scenario. We deal with critical industries. Think of a bad actor that's not necessarily a cyber actor who wants to do a terrorist attack on a hydroelectric dam. If you were an intelligence person, you'd say, hey, they stake out the dam, they see when people come and go, they're watching when the security guard changes, they do all sorts of things like that. Imagine not having to be there to surveil the dam. You can see when their data spins up, when are they using a lot of data, what types of data do they go, do they only have one or two paths for the data? Oh, look, there's cameras on there. All of that can be done by simply observing your network. So cybersecurity is also the idea of OPSEC security or operational security, because we have satellites that are measuring temperatures on data centers. A rogue actor can go and say, hey, something's happening somewhere because this data center just increased by half a temperature, half a degree of temperature. With AI, those bad actors can then correlate that to 15,000 other pieces of data and say, that's why that data center is getting hot, because this is happening over here. So from a security standpoint, it's not just the cybersecurity. It's really the idea of security in general. I know that sounds a little doom and gloomish, but it's reality. I mean, take away our networks today and then see what all of us do. Right? You know, we don't function very well.
All right, Greg, you had a question?
Yeah, so years ago, I remember conversations at shows like this about geolocation of uplink interference. And it seems like, I understand you don't want to share pricing or network configuration or something like that, but is there a way that you share or could share, or do you do it now, where you share information on, I remember with geolocation, if you had information from one satellite, it was good, but if you had information from like 5 satellites, you could like really pinpoint where it was. So is there a way for you to anonymously share information like that to, like, you could learn from you on where this uplink interference is? And then I guess with your last conversation, is there a way for you to share what the hacker thought up yesterday with Frank, so he knows what the hacker thought up yesterday as well?
Yeah, so there's a couple of things into that. First off, anonymously share scares me simply because you want to know where your data is coming from, because if you don't, somebody could give you bad data and you don't know otherwise. So the age of the API is here, right? So we're handing data back and forth between industries all the time at scale, very quickly and easily. It's like Thorsten said, right? If you have a model that one company created and they have this really great data on interference, they can hand it over to another company via API, and then they add that into their model, and so on, and it continues to build however you do it. So today, absolutely, we have APIs that we hand to our customers, and they can pull the data that's relevant about their sites. Now, what's interesting is, as we continue on our AI journey, we want to bring more fulsome data to those people, to those individuals, right? Let's take the example on geofencing or latency on an area, right? As you go out and you're going to get close to China and Starlink is going to get geofenced, when do you expect to get cut off? Well, we can send over and say, hey, look, we believe you're 10 miles away from getting your Starlink cut off. You know, do you want to buy a bigger package or something? You know, put the sales plug in there. But, you know, being able to hand that kind of data off is better for everyone. So yes, absolutely we want to do it, and we are doing it. Not anonymously, though. You have to be able to tie these things together, because if I give Frank an API, he has to know how to read that API, how to give the security key so that you can transfer that information securely between the two, and then we can work together on those things. When it comes to cybersecurity, that's why you partner with some of these firms. We use Palo Alto as an example for our firewalls. They have a cybersecurity agent that's part of their business. Their sole purpose in life is to watch that network traffic and see all those different things, and they get the latest from the government as well, and that updates their model, and that immediately updates all of our firewalls as part of it. So that's a real-time feedback that happens as part of it, but we rely on an expert like Palo, for example, where that's their goal, that's their business, that's what they want to do. They will see the network on our traffic, and that will feed the models for everybody else that's using their equipment. That's where you see that value add.
So, to talk about geolock, that's a good example also for how AI can improve things. So, in a traditional way, a satellite operator trying to geolocalize a signal, it will use basically three resources. A system that is based on a scientific principle of Doppler effect and delay of propagation and so on. It will use information from the other satellite operators and from its own fleet, and satellite operators do share information to cooperate on that. And it will use the knowledge on deployment of antennas and so on, so a database with all the terminals that are deployed in an area and so on. I will try to cross all that, and actually the NOC operator that is doing the geolock will use all that to first define an area and then try to cross it with the existing transmission. It will remember that there was something happening with a customer over there, maybe that it was just cut. So there is a lot of intelligence coming from the person, right? When using AI, we come again to the same thing. We can combine all that with a lot of other information, massive information, right? And we can easily identify anomalies, patterns that will help us to focus on a particular number of terminals that are most likely those that are generating the interference, right? and it will accelerate for sure the troubleshooting. Then, on top of that, it can help with other things because you can also have behind that AI automations that can provide alternative capacity for that service, so you can mitigate the effect of an interference, for example, by moving the service first, while in parallel you are trying to localize the source of the interference.
If I can just, I think you've hit on one of my business models or hopes. So if I look at the crystal ball, and try to think into the future, and we look at things like Starlink and the other LEOs, and there's a very weird fact that in 2023, the ITU had enough applications for 1 million satellites. So the paper million satellite concept is there. Probably not going to get there, but the crowded nature of spectrum, one of the business lines that I think a lot of teleport operators have is selling that data. Every single teleport is a monitoring station. So to your point, why not have all that monitoring data come in, have an AI go and actively, right now we're reactive to interference. We could be proactive to interference. And I think you're going to see things like the ITU become a little bit more of a police force or a little bit more of a, right now, the space industry is what I'd say one of the last bastions of honor. Space operators, it's like, oh, I'm interfering with you. Okay, I will fix that. What happens when that cooperation isn't there anymore, right? There's going to have to be some sort of, because you're talking about people's livelihoods and dollars and cents. People are not going to say, I'm not getting out of your way or what have you, and there's going to be regulatory to it. So I actually think it's a line of business for teleport operators to sell their monitoring and to sell their data and to get to the point of where geolocation is a proactive aspect. We're seeing interference or you're planning on deploying a terminal. You may not even, and we've dealt with it for years, the user doesn't know that they're going to interfere with somebody, right? But when you're planning a deployment model, you could plan, hey, you have a really high likelihood of interference in this area. And I think it'll end up being that way. But it's also a line of business for teleport operators.
And just to add one more thing to that particular bit, and I'm sorry, so this is actually where hallucination is a positive thing. So one of the things that I can do very, very easily, well, not very easily, I can do, not easily, is again, I'm going to look at a digital twin, right? I look at the geodata that I have of the Earth. I look at all of the coverage that I have. And one of the things that I can now do or hallucinate is I can place an antenna anywhere in the world with any kind of characteristic and then model for that particular characteristic anywhere in the world, whether I'm in the middle of buildings, whether I'm in a canyon, whether I'm on top of a mountain, all sorts of other different types of things. So I can actually generate that data in advance, even though I've never been there. I've never been in that particular bit. And so I'd be able to tell you as if you drive your vehicle or whatever else to that particular location, these are the characteristics in terms of satellite communications that you're going to get. And by the way, these are typically going to be the costs that you're going to get. So modeling that particular thing is also something, that's where hallucination is positive, because I can now have it imagine that data in advance.
Did you have some more to add, Will? Okay, we have a question from the audience.
Thank you. Leandra Bernstein, I'm a freelance writer and reporter. Question for Jose. You mentioned that you're looking at the lessons learned from telcos and mobile network operators.
Right.
Could you elaborate a little bit more on specifically what those lessons are? And then, if you'll indulge me, a second question for Will. You started talking about how you're training your models, feeding it the data, for machine learning, and then the AI. This might be a vague question, but to what end are you doing that? Just a few specifics.
Sure.
Yeah, so sure. I mean, they are doing a lot of things already, things that we can easily import in our industry. Some of them we have already mentioned them, but things like, for example, what I said about classification of alarms and events based not only on criticality, but also in cost impact and customers impacted and things like that, so that you can focus on things that are more relevant for your customers and for your business. This is one example. Early prediction, so when there is an event, and it's something we haven't talked yet. We talk about prediction, but early detection, I would say, early detection. So meaning that when something happens that generates an outage, there are often a lot of things that are happening just before. And this can be milliseconds, or it can be seconds, or it can be minutes, right? Or even months, right? So if you're using a machine learning algorithm to try to predict something, right, you can also use it to early detect that something is going to happen and immediately react. And another thing that you could use, and the telcos are using, is a self-healing network. So when something fails or is going to fail, right, I can find alternative routes and reroute the traffic in an efficient way before it is impacting customers, right? They are also using it, for example, mobile networks for the defining the usage of the spectrum to optimize it, right? To integrate into that scenarios of interferences, reflections, and topography and all that in ways that before they were extremely complicated to be used. In the resolution, you can use Copilot. I'm not talking about Microsoft Copilot, but a Copilot to your operation team that can guide the person in the troubleshooting, and it can go even to the field support, or it can go even to the maintenance and reparation in a data center or in a network site, where you can have an assistant that is telling the person, go here, remove that car, insert the other one. So the person doesn't need to go to the manual, etc. There is somebody guiding, a co-pilot guiding the person to execute a procedure in a very efficient way. What else? We haven't talked about it yet, but they are using AI as a marketing tool to detect patterns of usage by the customers and then offer product services or add-ons to the service that are adapted to the needs of the customer. AI can be used also to enhance products and services that you are delivering, and there is a huge list of things. I could continue for a long time. Last week I was in the Mobile World Congress in Barcelona. AI was everywhere, everywhere, and I spent time looking at what some of the mobile operators are doing there, the vendors are doing, and I was really surprised by how far they are in applying AI in the operations and in the marketing and in product development and so on.
And just to build on the marketing one, you asked the question, so it's going to require a shameless plug to respond, but we're building our Sigma product. And what that is, how do you, to what end, I think is really the question for AI. How do we see ourselves using AI? We see it enabling our customers' experience to improve on the edge. We want to build our abilities to do edge computing and have more of it work for the customer, for their experience. So we talked about a couple of the examples right now. Like we can see today latency in time at locations in different areas. We can see geofencing. We can see weather events. We can see all of this stuff. The data exists, but I don't have it going to my customer to say, hey, Mr. Customer, you're about to get in a weather event. We're going to switch your traffic over to a geo network because Leo's going to be offline and we want to make sure you have a seamless experience. We do have our traffic in SD-WAN today. So we have all the SD-WANs bringing all these links. I think I've had 19 on one site or more at this point. It keeps growing every day, every time I look. And you're bringing LTE, you're bringing Starlink, you're bringing OneWeb, you're bringing Geo, you're bringing microwave, and you're trying to decide which of those links is going to be the best link for you to use. And, well, it's raining, so you need to go over to C-band. Well, not all the traffic can fit onto C-band, so which traffic are you going to fit onto C-band? You can make these decisions if you're looking at that right data and you're helping adjust those SD-WANs to be able to flow the right path. So step one is make sure you're getting that high reliability, that high availability, which we're seeing now with SD-WAN on it. Step two is make it better. Right? How do you make sure your traffic steering? How do you make sure your application steering? How do you change your sessions to go from one to the other? How do you make it secure? You add a firewall into it. How do you make it totally reliable? So now you're predicting that there's a weather event that's coming and you're going to have to fail it over ahead of time and you move your voice lines or your calls. How do you tell the customer this is happening and it doesn't just happen in the background and then they start to wonder why the system isn't working? How do you give them a tool on the edge where they can ask a question and say, hey, why is my system slowed down? Oh, well, we see a weather event coming. We're getting ahead of our games for you. So there's a lot of ways it can be used and leveraged, but all of it's based off of the data that you have in the background and how you teach your machine to do it. And to Frank's point, he's spot on. data and selling the data out at some point is really going to be an important side of it. How do you give those APIs to customers so that they can make more intelligent decisions about what they're going to do based off of what your AI is seeing? Good question.
Great. We have another audience question.
My name's David Robbins, and I had questions about, with the rise of CubeSats and startups with lower budgets, what are the barriers to entry to implement cybersecurity? And also, with the increased number of these missions that may or may not have robust cybersecurity, what security risks does that have for the whole system, all different projects, that kind of thing?
I'd love to take first crack, if that's all right.
Go ahead, Bill.
The one that scares me to death at the moment is we're seeing this increased number of satellites, 1 million satellites. Frank, I didn't know that fact. That's a super interesting fact. Did you know Starlink publishes the data on how many moves they do autonomously on their satellites? Last year, it was over 17,000 moves their satellites made to avoid space debris. When you talk about security, that's the thing that scares me. It's not the cybersecurity, it's the physical security. If they lose contact with some of those CubeSats and they do a collision in space, especially as we start to get to a more populated area, it can have a knock-on effect and really damage the whole orbital plane for everybody, above and below in many cases. So the first thing that occurs to me on your question is that. How do you make sure that you're securing the domain in such a way that they're able to make it aware for everybody else in a gentleman agreements kind of world until we can figure out how to get a police force in space? If you figure out how to get a police car in space, let me know. We can work on it together. When you look at the security side of things, or maybe I'll take the question a little bit differently into an AI form, that scheduling is the biggest problem for those CubeSat providers. They can't afford to buy the ground infrastructure that Starlink has put in place as an example. And that's where AI and scheduling is what we're talking about. How do you give them time on an antenna for the 7 minutes it's going to pass overhead and see that teleport? And then at the next teleport, it needs another 7 minutes and so on around the world. They don't need to buy an antenna at one place because capital is going to be your biggest challenge as part of it. The CubeSats has a very low startup cost because your cost to launch is low, but your cost to support that asset and make sure that asset doesn't run into it, it's a much bigger problem.
Great. Thorsten, Frank?
The cybersecurity on the CubeSat, so again, kind of following on Will here, flight operations is done very remotely, which then, again, you kind of get a theme of my conversation about attack surface. It scares me when, general sort of, and I'm not going to pick on universities, but a university does a CubeSat and they have all these flight operations. Where's that network attached to? Who's operating the network? How do we know that somebody's not going to get control of that flight operation? There's that nasty theory called Kessler that he's referring to. That's, to me, I think it's, things like zero trust have to be a standard now. It has to just be implied. And in a lot of cases, flight operations need to be private. Like private networks and control where they're accessing, because there are the guys in the black hats that probably would love to fly a satellite around in circles.
So if I can add something on that, flying a satellite, small or large, without security is a big concern, right? It's a major concern. Actually, if you look at the security layers of a satellite operator, and I have worked with a few already, the satellite control is the highest level of security, with a lot of things that are completely disconnected from the entire world, right? Not to talk about the encryption on the communication links to the satellite, that some of them are really very hard. And ourselves, we are working now on projects where we are going to onboard quantic key distribution systems in satellites, right? So we haven't talked about the quantic world, but it's going to be extremely sensitive to security, all that. So I wouldn't fly a satellite without any concern about security.
All right, we have time for one last question. That's going to go to Aziza.
Hi, Aziza, representing Expanso. Will already has touched a little bit on the edge compute, and I had a question how satellite operators like Hispasat and others integrating edge computing in enhancing real-time decision-making in contested environment, and what challenges still need to be solved. And I think other panelists also can add on the challenges maybe more. Thank you.
So Well, I would say edge computing, it doesn't need to be related to AI. It's a component of a service that you can package with the connectivity and so on to provide local gathering and processing of data, right, without bringing it to the cloud, right, or maybe pre-processing before you bring it to the cloud, right. And this is something we're doing. We're offering to our customers, and you do too, and all the satellite operators and service providers are working on edge computing applications, right? And now AI is a layer that you can put on top of that layer, so it's another module, right, where you can use machine learning or any other technique coming from data science, analytics, and so on, to process that data locally before it goes to the cloud, which can be efficient for multiple reasons. One of them is delays, because you can process it locally, right? The other one is capacity saving, because you can have massive data that you can compress into results that you can then bring to the cloud or bring to the data center or the headquarters or whatever, right? So this is the way these things are seen from our point of view and how they are combined. So it's basically, at the end of the day, service components that you put together, right? I talk very often about the Lego model when we're building services. So we have standard blocks, and you can build a castle or a car or whatever just by putting all of them together. AI is one of them, edge computing is another one, and they can also be combined, right?
And in terms of well, edge compute is a two-edged sword. So it gives you lower latency, more flexibility locally, but now what you're also doing is you're now putting an asset in the network of a customer or somebody else where you might not be able to control everything that they're doing. So one customer, and I guess that's kind of back to the CubeSat question, might not care about security, might not have invested in security. Now you've got an asset that has full access to your network sitting in a not as secure network as a customer that has invested a lot in security now compromises the entire network.
So you're exposed. Right?
So that's right. So by putting edge AI or edge compute into different types of places, you open up new areas of exposure, right? So that is one of those things that are there. What we're seeing is, and Frank mentioned it as well, this whole aspect of zero trust, this whole aspect of being able to, of adding trust to that platform, so that inherently, if it gets compromised, if it gets hacked, you can safely remove it from the network. You can detect that the device has been hacked in a very, very reliable way, right? So that if you are putting it, into an environment that might compromise you, you have a way of mitigating that fairly quickly.
Okay. Well,
Can also use containerized solution, right? So then only particular applications will be activated.
So we use the containerized solutions too. Containers, VMs, VLANs, VRFs, we separate it in every way that you can, but their points are still valid because you have to have a management layer that talks to all those VLANs. So if your management layer ends up getting hacked, then it has access to everything. But if you have one customer in one VLAN and then you have another customer in another VLAN and this customer gets hacked, the probability of going sideways is low. It just depends on which portion of it you're talking about. So containers does help, but it doesn't solve it. And
hackers are now starting, software is getting more and more secure. Well, that's a very controversial sentence I just said there. But again, from an AI perspective, hackers are now actually looking below the software layer. They're looking at hardware layers and attacking firmware, attacking the different subcomponents that are within a hardware component. Because once you've established a footprint at hardware level, you can put in whatever security mechanisms at software level, you can compromise them because you own the processor, you own the underlying hardware. That's an emerging trend that we're seeing in that community.
all right, great. We have less than a minute, so real quick, 2 or 3 words. What AI-driven innovations do you see in your crystal ball coming out for the ground segment in the next few years? José?
Yep. Well, so I see AI today moving from, in our ecosystem, moving from the POC little by little to assist, and then little by little to automate, and then little by little to become embedded in the systems and in the operations and in the services, right? So that's the trend I see on one side, and then I see in the future a large offer of services where AI is part of the component of the service itself. So, for instance, if I can just give one example,
Real quick, we're out of time.
Software-defined networks. So networks that are intelligently redefining themselves based on weather and traffic and cost and 20,000 things that can happen, right?
Well, Frank, any final word?
I think automation is the final word myself.
Yeah, automation, and then I'll tag on to zero trust architecture and containerizing has to be designed that there is not a single path of dependency on the management side. AI helps model that, where we're not thinking of all the different permeations of it. I do think AI will be deployed on a white hat side of things, probably catching up to the guys that are already doing it on the black hat. So, you know, we have products that we're quote utilizing the dark web to help hide from the dark web. So I think it's going to be security.
All right, great.
And I've got 5 words. You ain't seen nothing yet. That's all I'm going to say.
All right, well, we are over time. Quick thank you to ChatGPT for writing my questions. And please feel free to stay and talk to these guys after.
Thank you.
Thank you.